This is a reminder that you should feel free to take as much time as you need to write all of the notes down and think about them. Pause the video at your own pace. Well, hello everybody. This is section 4.2, Sets, Sentences, and Inequalities. And we're going to just talk about sets in general. We've been using these brackets for a while, and we've been using them to represent domain and range. Well, mostly domain, but today we're going to learn about how to intersect them, how to find the intersection of sets, and later on how to find the union of sets. Anyway, if you just had these 5 numbers here and these 5 numbers here, if you found the intersection of the two, that would be trying to find the numbers that are common to both sets. So you can see the numbers only 5 and 7 are in both of them, and since no other numbers are in both, then the intersection of this set and this set is 5 and 7. You have to find the set containing elements in both sets. So for example, if you want a visual representation, then it would be there's set A, all the points here within this triangle, and here's set B, all the points inside this ellipse. The intersection would be where they overlap. And if they don't overlap, then there's nothing in the intersection. This is the symbol right here for the empty set. The intersection with A and B is nothing. Find the graph of x such that 3 is less than x, and the intersection with x such that x is less than or equal to 5. So let's graph these individually. You can see that here are all the numbers such that 3 is less than x, or x is greater than 3. Notice the open dot here. We're not including 3, we're including anything that's greater than 3. And here there's closed dot, and we're including everything that's less than 5, less than or equal to 5. So the intersection would be the points that just got highlighted twice that are in both graphs. So the answer would be these right here. Everything in between 3 and 5, and then including 5 and not including 3. Because 3 isn't part of this graph, so it shouldn't be part of the intersection either. So let's do that again. Let's graph x such that negative 3 is less than or equal to x. The intersection of x is such that negative 1 is less than or equal to x. We've got here, and what between these two number lines, which numbers got shaded twice that are in both graphs? We could see here everything from negative 1 all the way up to positive infinity. So that's how you shade it in here. And notice that there's a closed dot because negative 1 is included. And so we can say that the intersection is written like this: x such that negative 1 is less than or equal to x. You can also write it using interval notation from all of the numbers negative 1 up to positive infinity, including negative 1. This bracket includes negative 1. Well, let's talk about, that's the intersection. Let's talk about the union. If you had these same two sets here and you combine them together, then you write it out like this. Any number that's in either of these gets put into the union of the sets. You don't have to write the numbers twice, like 5 and 7 occur twice, just write them once. And it's a common courtesy to organize these from least to greatest so that people can read them. So you get 1, 2, 3, 4, 5, 7, 9, 11. Those are the numbers that are in either this or this. And the union is the set containing the elements in either set. So here's all the points in triangle A, here are all the points in ellipse B. The union is going to be this whole thing, all of these points. So for example, if you wanted to graph x is greater than or equal to negative 1, with the union of x is less than 2, then here are all the numbers that are greater than or equal to negative 1, and here are all the numbers that are less than 2. And so then the answer, if you want to take the union of this and this, you ask yourself, what number got shaded on either this or this graph? That's all the numbers. They overlap. So you have the set, or the interval from negative infinity to positive infinity, or all real numbers. You can write it like this if you want, with the extra line kind of in the middle. Example 4, graph x is less than or equal to negative 2, with a union of x is greater than 1, and you can see here you get the union of this graph plus this graph gives you all the numbers from negative infinity to 2, and I want you to tell me what this would look like using interval notation. Conjunction. Conjunction is a sentence formed by combining two sentences with the word and. Remember, you can use, if you ever need to, you can use an intersection symbol. We call that a cap. That's the name of the actual symbol, is the cap. Versus the cup. Cap and cup. Isn't that cute? Here's the cup. Here's the cap. Here is what we want to do next. Combine 4 is less than x and x is less than 8. If you combine those together, you can kind of just write them as one number sentence. 4 is less than x is less than 8. And you can graph all of those points that are in between 4 and 8 right here. Notice that 4 and 8 are not included. That's why we use parentheses in this interval notation. This is all the numbers between 4 and 8. Solve and graph -3 is less than 2x plus 5 is less than 7. Well, you can subtract 5 from all 3 parts of this number sentence. And when you do, you get -8 is less than 2x is less than 2. Divide all the terms on all the sides by 2, and you get -4 is less than x is less than 1. Graphing these points, we put an open circle on -4 and an open circle on 1, and so then we can describe all these points in interval notation as -4, 1. Solve and graph this. Well, in order to isolate x, we have to multiply all the terms on both sides by 2. That gives us this. Then we subtract 5, and that gives us this. Here we can divide all the parts on both sides by a -3. And one thing you have to remember is that when you divide an inequality by a negative number, you have to flip the sign. Multiplying or dividing by a negative number, flip the sign. So this used to be less than, now it's greater than. It used to be less than or equal to, now it's greater than or equal to. You can see you get 4.3 repeating is greater than x is greater than or equal to -1.6 repeating. And so we can put the dots right here. Notice that this one is -1.6 is less than or equal to x. So this is including -1.6, but this is not including 4.3. And you write it like this: including, not including. Disjunction is a sentence formed by combining two sentences with the word or, as you'll see right here. Solve this or this. So we're going to combine these two into one number line. Solve them individually, and you get x is less than -1. And that gets graphed right here. X is less than -1, not including -1. Now would be as good a time as any to talk about my president of this audio check. The audio check president today is Dwight D. Eisenhower. You won't find him on this number graph. This is only of numbers. So we get an x is greater than 6, and that's what this is right here, not including 6. So you can write the union of -infinity to -1 with a union of 6, infinity. That's talking about both of these together in the same collective set. It's a disjunction. Here, when you want to isolate x, you multiply all the terms on both sides by 2. Do the same thing here. Since it's a positive number, it doesn't switch. Even though you're multiplying, even this is -1, it still doesn't switch. It all depends on what you're multiplying both sides by, not whether or not the numbers that you see there are negative or positive. Anyway, you get 4 minus 3x is less than -2. Subtracting 4 from both sides, you get -3x is less than -6. X is greater than, remember you flip the sign here because you're dividing by both sides by a -3. You get x is greater than 2, which is how you graph this. Not including 2, it's all the numbers above 2. Or all the numbers that are less than or equal to -2/3. That's right about here. So you put a solid dot and you shade to the left. And that's how you describe, here's the interval notation. From -infinity up to 2/3 is this first part, including 2/3, with a union of 2 to -infinity, not including 2. Anyway, I'd like you to start assignment 4B, copy the problem list, and do the first problem, and I will see you in class.